All right, this is Mr. Matthews. I'm going to go through part two of the study guide here, role of organisms and ecosystems, and then end with some succession. But looking at the picture here, this is a food web. And so the important thing to know about food webs, arrows indicate energy transfer. So when looking at the producers, grass. Grass is the producer. And then down here we have a chart that serves as who are the consumers? What do they do? What do they eat? What level do they serve? So the grasshopper right here, that's a primary, that is a, of course, that's an herbivore because it eats plants and it's a primary consumer. The rabbit, on the other hand, right here, that's also an herbivore, it eats plants, and that's a primary consumer. I'm going to put P for primary. The mouse right here. So the mouse can either eat the grass or eat the grasshopper that eats the grass. So that means that it's an omnivore. It's a meat eater and a plant eater, so it can be a primary or secondary consumer. All right, primary if it eats the grass, secondary if it eats the grasshopper. It can exist in both worlds. The sparrow here can also be, it's an omnivore, meaning it's it only eats meat, so that's a carnivore. And it just really depends on where it's getting its energy from. So it's either going to be a secondary consumer, or if it eats you go from grass to praying mantis to sparrow, and that can be secondary, that can be a tertiary consumer. Okay, I'm going to erase this a little bit. There we go. Praying mantis, again, praying mantis is eats the grasshopper, so that's a carnivore, and that's secondary. The garter snake right up here, so that's going to be a carnivore, and all right, primary consumer, secondary consumer. All right, spiders right here. So spider's going to eat the grasshopper. So that's going to be a carnivore, and that's going to be a secondary consumer. All right, toad eats the grasshopper, eats the spider, eats the praying mantis. Carnivore, so it can be a secondary consumer, or it can be a tertiary consumer. And grasshopper, praying mantis, the toad, right, that can also be a tertiary. So hognose snake right here, right, that's going to be a carnivore, and that's going to be a secondary consumer. But the hawk right here can be tertiary or carnivore. That can be a tertiary or what we call a quaternary, okay, because you could have the grass to the grasshopper to the garter snake. So the hawk, that would be a tertiary, but you could have grasshopper, spider, sparrow, hawk. 1, 2, 3, 4 levels. So quaternary. So there you go with the consumers. I'm going to erase this so we can go down. All right, moving on down a little bit to, going to blow this up. Okay, moving on down. Decomposers, and we'll just start with the initial energy source. That everything comes from the sun. But the important thing to know about decomposers, if we have, let's say, we have the grass, we have grasshopper, and we have a mouse, but eventually everything is going to be decomposed. Eventually everything is going to die, and decomposers take care of all the dead stuff. If we didn't have decomposers, then we'd have just mountains and mountains of dead stuff. So everything eventually points back to the decomposers. And that can be bacteria, that can be fungus, whatever we're talking about there. So go ahead and erase that. And moving on to the actual energy pyramid. Flows of energy. I'm going to back up just a bit so we can fit everything else in here. Okay, which level includes the producers? Producers are the bottom here, so that's level A. The consumers, B, C, and D. Multiple answers. Herbivores are the plant eaters, the grasshoppers. They eat the plants, so they are the herbivores. Which level is the second trophic level? B is primary, C is secondary. Which level is the third trophic level? D. Which level has the greatest number of organisms? It's always at the bottom. That's why we are a pyramid. A. Which has the least? D. And what happens? Energy is lost or not available. Moving up levels. So what that means, again, that's not entirely accurate because we never lose energy. It really just transfers from a different phase. But the grass gets eaten by the grasshopper. The grasshopper uses that energy from the grass to grow and reproduce and develop and do work. And so as it's growing and developing and doing work, those energy molecules are being broken apart. And when that happens, you're releasing heat. So there's never 100% of the energy that's available to the next level. So it gets less and less as you move up. And that's why we don't see a lot of organisms being up a letter D, or even if we put a letter E up, that's just not going to exist. So here's just a different picture of an energy pyramid, saying the same thing that food chain and food chain. So we're looking at cycles, moving on to cycles, because all of this wouldn't happen if we didn't have cycles that were recycled into the planet. But the two that you'll need to really worry about, carbon and nitrogen. Carbon is the base for all things considered organic. So glucose is organic. It has carbon, C6H12O6. That's glucose. That C is for carbon. Carbon dioxide. Carbon. Okay, it's a large part of the cellular respiration or the energy cycle. We just have to understand that. Nitrogen, we need nitrogen for DNA, for proteins. And when we're, nope, I don't want that. I actually want to show you the other kind of thing that's really important here is the human impact. Right? Looking at this picture, right? How do humans impact the carbon cycle? Well, we cut down the trees, so there's less photosynthesis. Well, we burn more fossil fuels over here. All right, so we're putting carbon dioxide back into the atmosphere. Okay, so we are directly impacting, and by the way that we farm and raise animals, we are directly impacting the carbon cycle. Nitrogen cycle, again, we're burning fossil fuels, so we are putting more nitrogen in the atmosphere. That leads to acid rain, not good. Making all these synthetic fertilizers that lead to runoff and eutrophication and therefore. So we have an impact, humans do have a big impact on these cycles. So you would need to know that as well. So switching to another part, succession, last part. Talked about this in class, especially for your Blue Day people. We really talked about this in depth. But looking at succession, and just a general description of succession is that things naturally change over time. Succession is all about the story of who goes where and when, right? There is a natural order, a natural progression of who's going to grow at what scenario. So if we look at primary succession, what would you see around you if you're a producer in a community or undergoing primary succession? So I'm going to start with like a rock, because that's an exposed rock. And we'll say for whatever reason, maybe it's a volcano because all that volcanic ash dries and becomes rock. That's what Hawaii is made of. Or maybe it's just a glacier retreats. But then you're going to get things like lichens and moss. Those are what we often call the pioneer species. And then they go into, then we get some shrubs and bushes, and we get trees, then we get larger trees, and this is our climax forest. But this is just a general order of how primary succession exists. And succession exists because of, succession exists due to disturbances. Something happened. All right, the glacier retreated, that's a disturbance. The volcano erupted, that's a disturbance. Okay, disturbances happen and cause succession to happen. Primary is where there's been no growth before. All right, bare exposed rock where nothing has grown out before. Eventually, we get trees growing there, of course, depending on the biome or whatever. But mostly, this is the general progression of what happens. Secondary succession down here this is where there's again regrowth. So in Virginia, we often find that we have Indian grass. We used Indian grass and we used goldenrod. Those are kind of like the, sometimes people call them weeds, but they're actually really pretty. All right, those are like the pioneer species, and those leads to something like dogwood, which is considered a tree, even though it's a shrub. Dogwoods get replaced by pine trees get replaced by oak trees. Eventually we have mature oak trees. But this is typically what you would see, and there's some other things involved, but this is a very simple way of looking at what happens in Virginia. The oak is it's natural around here. This is what we would see if, again, we just let things go. Now a disturbance actually, due to a disturbance might reset the succession timeline. So if we have like a fire, if we have a fire right here, it knocks out all the dogwood, then we're going to go back to succession again. If we clear the pine trees because we want to make firewood, or we just clear a forest, cut down trees for like housing or whatever reason, then we're going to reset the succession timeline. So it really depends on what we're using and what the disturbance is. So what ecological impact could a hurricane have on a stable ecosystem? It resets the succession timeline. And with that, again, we talked about biodiversity. The more biodiverse you are, the more your ecosystem is going to be able to withstand a disturbance. So we might not knock out all the dogwoods or all the pine trees in a fire, so that's really good. You might not knock out everything in the disturbance, but biodiversity is a good thing. It just means you have a greater chance of survival. So moving on to the last page here. I'll make this too long. But this is all about, where we live, Chesapeake Bay. We live in the Chesapeake Bay watershed. It's important we kind of just think about everything we've talked about this year in relation to, us and cause and effect. And we did this in our class. We talked a lot about this in STEM explorations. I mean, this is kind of what sustainability is really all about. So let me get out of here. Okay, let me center this. But again, this is cause and effect. So the human cause. So we reduced forest cover. So what was the cause of that? For development. Okay, we wanted to development. So the consequence to the environment, the non-living, is that there was more runoff. Right? We had more impervious surfaces, so the water runs off to, and we have more soil degradation, but more runoff to the streams, and that, again, this is a key component of eutrophication. All right, dead zones. Increased chemical use, causes of that, industrialization. Right, we did this. We created factories. We created fertilizer, increased chemical use. So consequences to the environment. Right? If we're talking factories, of course, that's going to be air pollution. But again, more chemical use, more runoff. Air pollution leads to health issues, not just in humans, but to just animals in general. And again, the key word, eutrophication. Lastly, intensive farming. Why would we farm? Farming is not natural, right? We remove trees so we can farm, right? Whenever we weed, whenever we farm, whenever we're trying to landscape, we are fighting succession. We're fighting it. Those weeds shouldn't grow there. So what are the causes of farming? Why do we need to farm? Well, we need increase in population, right? Causes more food. We need more food. So the consequences of removing more land for agriculture, again, we have fertilizers that we're just dumping tons of fertilizer into farming. We have soil degradation. All right, erosion, runoff. All right, and that again leads to eutrophication. So eutrophication, I mean, when we say consequences to living things, we're referring to the fact that a lot of what's going to end up in the water is not going to be there anymore because it causes dead zones. So, and that can cause a whole other slew of issues. Socially, it can cause economically, environmentally, lots of impacts when dead zones are involved. So this is the study guide. Please email me with any questions, but I will get this up on YouTube and go ahead and check your answers.